To allow us to make very precise measurements of the aluminium cylinder you're going to determine the density of, one of the instruments we've given you is a micrometer screw gauge. And let's just have a quick look at this first up. And the first thing I want to show you is as you tighten the micrometer screw gauge, you tighten it by turning the ratchet at the end until the ratchet just clicks. You don't grab the barrel and grind it tight. This is not a nutcracker, it's not a shifting spanner. It is a measuring instrument, so we need to treat it fairly delicately. Now let's have a bit of a zoom in on the scale there, a little bit closer so we can actually see what's going on. When the jaws are completely shut, the measuring point is this datum line, the horizontal line there, and that's lining up with the 0. Now something I want to show you with the micrometer screw gauge is as I open it, I make one full revolution and I go through 45. At the point you come to 50, you're back to 0. That gap is now open half a millimetre. And so I'm reading that as 0.45 millimetre there. That's actually 0.50 of a millimetre. And you can just begin to see a half millimetre scratch appearing there. I have to rotate that one more full revolution to get it out to exactly 1 millimetre. And now I can just see the 1 millimetre gap. So one of the issues with the micrometer screw gauge is first off to decide whether you're just out to a half millimetre or a full millimetre mark, and then the reading off the barrel gives you the extra decimal places that you need. Let's have a look at an example. I've got a brass cylinder here. I'll use the micrometer screw gauge to measure the diameter of that cylinder. So firstly, I'll open it right out until I get it just wide enough so I can just slip it over the cylinder. Now, as I tighten it up, I use the ratchet on the far end here to tighten it up until the ratchet just clicks. I'll just open that out again, tighten it using the ratchet, and you can just hear the ratchet clicking there. Now, what I'm going to do is I'm going to lock that in position so that I can now very carefully remove that cylinder, and the micrometer is now latched in position. Now to read that scale, I look on the main scale, I can see the 15 millimetre mark, then 16, 17, 18, 18 and a half is very clearly visible. The 19 millimetre mark is just coming into view. So it's a little bit over 19 millimetres. I can see the 5 is lining up there, almost on the 5, so I'm going to read that as 19.05 millimetres. And so that is the diameter of my particular little brass cylinder. I'll just unlatch that for a moment and show you if I was a little bit further around here. That is actually 19.45 millimetres, even though I can almost begin to see the half millimetre mark down the bottom there. Sometimes it's a bit difficult to see, but if you're on the side of the barrel which says you're up in a 40 or 45, then you should probably be adding to the most clearly visible mark. So that'll be 19.45. If I go another perhaps 2/3 of a revolution up to about that point, you can now clearly see the 19.5 millimetre mark is visible. The 20 millimetre mark, you can just see the beginning of the 2 for the 20 is not visible. So I'm bigger than 19.5 millimetres. So that's 19.5 millimetres, and I have to add on the extra 0.3. So that would actually be 19.8 millimetres. Going back to my original cylinder, just double checking that reading again, wind it shut, and again, as the ratchet is clicking, that is now, it's dropped down to just below 19.05. It's about 19.04. So perhaps I'm going to have to say 19.05 plus or minus 0.01 of a millimetre to take that into account.